So this would be the neuromuscular junction. This is the T-tubule. The white balls are calcium, and they're inside the sarcoplasmic reticulum. The blue would be myosin. The green is actin. The pink is tropomyosin. The black beads are troponin, and the yellow is ATP.
Muscle contraction occurs as a result of the sliding filament theory, which is just when actin and myosin filaments slide in and out between each other to form a muscle contraction.
Okay, so a nerve impulse arrives at the neuromuscular junction, which causes a release of acetylcholine. The presence of acetylcholine causes the depolarization of the motor end plate, which travels throughout the muscle by the transverse tubules, causing calcium to be released from the sarcoplasmic reticulum. In the presence of high concentrations of calcium, the calcium binds to troponin, causing its shape and so moving tropomyosin from the active site of the actin. The myosin filaments can now attach to the actin, forming a cross bridge. The breakdown of ATP releases energy, which enables the myosin to pull the actin filaments inwards, so it's shortening the muscle. This occurs along the entire length of every myofibril in the muscle cell. The myosin detaches from the actin, and the cross bridge is broken when an ATP molecule binds to the myosin head. When the ATP is then broken down, the myosin head can again attach to an actin binding site further along the actin filament and repeat the power stroke, which is where the myosin immediately starts to pull on the actin. This process of muscular contraction can last for as long as there is adequate ATP and calcium stored. Once the impulse stops, calcium is pumped back to the sarcoplasmic reticulum and the actin returns to its resting position, causing the muscle to lengthen and relax.
Rigor mortis is the stiffening of muscles. When a person dies, calcium leaks from the sarcoplasmic reticulum and binds to the troponin. Then it goes through its normal contractions, but without a constant supply of ATP, it stays contracted.